Good morning, everyone. So to start off with today's presentation, I will be walking you through the entire functionality of our web application. So this is the home page where we have a browse by category section, a featured product section that shows the featured products of our application, and why choose us section, and also a customer testimonial section. Next, moving on to the products page. We have 10 different products in our web application, along with options to filter and sort by price, rating, and relevance. And over here, we have a separate section where users can search for the products and also filter by categories, price range, material, customer rating, and also reset the filters. Next, moving on to the categories page, we have 6 different categories of furniture in our application. Moving on to the about page, we have a section which consists of the 5 team members, along with the value section and a journey section, which shows our journey from 2010 to 2025. Next, moving on to the contact page, we have a form and a map that allows the users to locate our store. Moving on to the frequently asked questions, we have the most frequently asked questions from users in this page, and the shipping and returns page shows the different methods of shipping and also the returns policy. Next, moving on to the warranty page, we have the warranty terms and conditions for different types of furnitures, and the care instructions page consists of the care type that we should pretty much make use of for each and every type of furniture. And the store locator page consists of a map that allows the users to find the store, and the privacy policy page helps the users to know more about how the data is protected. Next, moving on to the terms and service page, it shows how the intellectual property and limitation of liability is governed through the web application, and the site map allows the users to easily navigate through our entire application. And over here, we have the View 3D Model button that consists of the 3D model of the vanity table, along with room settings and tables of and settings of the vanity table. We have these buttons which we can use to reset, save, edit, and also delete the design. And moving on to the code of the vanity table, over here we have the design control panel settings, room settings, and the vanity table settings. And right below this, we have all the geometry and the mathematical computations that is used to render the vanity table 3D model. And right below that, we have event listeners that is used to dynamically update and display the changes when any updates are made to the vanity table 3D model. Next, moving on to the 3D model product description page of the TV entertainment unit. Similar to the previous one, we have a You May Also Like section that consists of similar products. And over here in the View 3D model page, over here we have unique options like Java extension, where we can pretty much open the drawer and have a look at how the entertainment unit would look like, and also toggle between the cable management options. And moving on to the code of the entertainment unit, we have the design control panel settings, room settings, and settings of the entertainment unit, and all the mathematical computations in order to render the 3D model of the entertainment unit. And finally, we have event listeners that is used to dynamically render the 3D models after any updates or changes are made to the model.
Let's start with the wardrobe. As you can see, it features a minimalist design with customizable dimensions, width, height, and depth, allowing you to tailor it to your space. The interactive panel lets you adjust colors for the door, frame, and shelves, and even tweak the LED lighting intensity for ambience. The physics-based interactions powered by Canon.js ensure a realistic feel as you explore its functionality. The wardrobe is constructed through composite geometry primitives using 3-box geometry for all structural components. The frame consists of 5 position panels: left, right, top, bottom, and back, with configurable dimensions controlled by wardrobe width, wardrobe height, and depth parameters. The sliding doors utilize separate geometries with positioning to ensure proper alignment with the frame while maintaining a small gap for realistic appearance. Door sliding mechanics are implemented through positional transforms rather than animations, with the door position parameter controlling their offset along the x-axis. Next, the leather sofa. This model highlights a contemporary style with adjustable scale and fabric color options. The leg design and shines can be customized, and the ambient lighting adds a warm, inviting touch. Thanks to 3.js, you can rotate and view it from any angle in real time, while Canon.js enhances the tactical experience. Both models are fully interactive, offering a 2D or 3D view, and are designed to help you visualize your dream furniture. So I'll explain the technical aspects of the leather sofa 3D model in this code. This code creates a 3D sofa model using a 3.js, a popular JavaScript 3 library. So the 3D sofa is composed of multiple geometric primitives combined into a group. The base is box geometry, 4 legs are cylinder geometries, and the model uses 2 material types, fabric materials and the leg material, and also all mesh components are added to appearance of a group that allows uniform scaling and positioning. The model is illuminated by ambient light, providing base illumination, 4 points lights positioned at different corners to create realistic lighting effects. The code computes vertex normals for each geometry to ensure proper light reflection and uses 3-dot double side rendering to make both sides of surface visible.
Today I'm looking at the interactive 3D bookshelf design. This interface built with HTML tags serves as a direct controls panel for dynamic JavaScript and 3.js backend. Imagine the main controls panel is our primary tag for settings. Within it, interactive text like sliders and instance bookshelf with an color pickers like wood color pick allow you to customize every aspect. As you interact with these, JavaScript instantly read the new values. The data then arrives at the create bookshelf function, rebuilding the 3D model in real time, which you see rendering within the canvas container tag button. Also key tags like view 2D button or save button trigger JavaScript to switch camera views to initiate process like saving your designs to zip file. Often use model tags for confirmation. Even loading designers use a hidden file input tag managed by script. In short, these HTML tags are not just static labels, they are in interactive touchpads that JavaScript leverages to create a fully and responsive 3D design experience. Okay, this provides a dynamic way to view a copy table model and a tailor to individual preference. It offers a range of customization options from dimensions to materials like lighting. The primary feature is to interactive 3D model is display. Users can rotate, zoom, and examine copy table from various angles. The sidebar on the right provides a comprehensive set of controls organized into sections for room settings, table proposition, and lighting. Users can adjust the vertical room dimensions, room width, room depth, and color, allowing them to see the copy table in different environments. The copy table settings section allows to detail customization for the product itself. Users can modify with the table width, depth, height, glass thickness, base color, glass opticity, and base tightness. Coffee table HTML, a 3D visualization tool that lets users design and customizable glass coffee table in real time, built with cutting-edge technologies like 3.js for 3D rendering, Canon.js for physics, and Bootstrap 5.3 for sleek, responsive interface. This product showcases the power of modern web development and creating interface. User-driven experience imaging tool where you can traverse dimensions, materials, and lighting, see the changes instantly. Even save your designs for later, all for your browser. Whenever your desktop is mobile device, let the drive into what makes the application stand out. It's an example for 3D web technology. At the heart of the coffee.html, the 3D model is glass coffee table featuring transparent glass top of a shiny metal table set on a customizable roof floor. User can be adjusted table with depth, height, and glass thickness, change the metal color and shyness. The fine-tuned glass optically using into sliders and cool pickers. The room of itself is configurable with options to set its size and color, and the lighting, ambient, and directional can be dialed in for the perfect ambience. But remarkable is the real-time feedback. As you slide a control, the model update instant, rendered beautifully with the 3.js.
My name is Mifra, and let's take a look at the dining table product. Here we have the product details page with the product description and other products that the customer may like. Let's take a look at the 3D model. Here the customer can toggle between the 2D and 3D views. They can adjust the row measurements if they want. And here are the settings for the table to adjust the table measurements. They can also change the wood color as they want. And here they can choose between different leg styles for the table. They can save, edit, reset, and delete the design as they need. Taking a look at the dining table model code, here we have the CSS for the page UIs and also the HTML code. Here, if we take a look at the script tag, there is the 3JS code that we have used for rendering of the 3D model. Here's the code to adjust the row measurements, and here are the codes to adjust the table geometry, including the different types of leg styles of the table. And if we take a look at here, these are the different event listeners for when the customer makes different changes. And at the end, we have the animate function, which shows the real-time rendering of the 3D model to the customer. Let's take a look at the other product which I developed, which is the kitchen cart. And the page details are the same. And taking a look at the 3D model, customers can adjust the room and the different measurements of the kitchen cart. Here they can change the different colors, including the shelf color and the wheel color, which is in the bottom of the cart. And here they can change the different design options of the cart. And taking a look at the code, it's similar to the other models. We have the CSS and the HTML codes. And if we take a look here, we have the JavaScript code. Here we have the JavaScript code using 3JS. And here are the different functions for the wheel, for the changes to the wheels and the legs of the kitchen cart. and the different service geometry for the shelves and so on.
Positioning the camera you are looking to and drawing everything you see. We also have camera.js integrated, a JavaScript physical engine, which gets not fully utilized for complex interaction in these particular static models. It provides the capability to add realistic physics if needed in a 3D environment. So the model themselves, like the bed frame or armchair, aren't important as a simple complex file. Instead, they are built through these programmatically codes using basic 3D shapes and everything. This is a fabric armchair. So I think cubes for the main structure and the cylinders for the legs. These are cylinders for the legs. These shapes are assembled and positioned from the complete piece of furniture. We define the look of these shapes using materials. Case offers various material types. We have mesh form material for things like the bed frame and fabric armchairs legs. And the armchairs wood, which gives them a classic shiny appearance. For the armchairs fabric, we use a standard material, a more advanced material that allows for realistic light interaction using properties like roughness, making the fabric look more realistic. The control panel allows us to interact with models in real time, changing the fabric color, wood color, and the more things. And also the lighting conditions, demonstrating the flexibility of creating and manipulating these models directly in the browser. This combination of building models with geometry and apply for materials, all rendering by T.js, delivers this interactive visualization experience directly in the web. Thank you.